right, we're back. This is Techmath1. We're looking at the review for the chapter 9-10 test. And so, shoot, there goes a couple of markers. So the review packet is actually after all your homework in the packet. And so it's just these blank problems. So that's the problems I'm going to work out on the board now. All right. And there's also a written copy ready. So if you already get it, then I guess you don't have to watch this video. All right. So solve for A. So look at all these variables and we're solving for A. And so what I'd like to do just really quick is I want you to think about when it was easier problem, like 2A plus 7 was equal to 17, something like that. So there's only one variable in this equation. And we isolated the variable, we subtracted the 7 from both sides, and then we divided by 2. So we had 2a is equal to 10, and then we divided by 2, and a was equal to 5. And so a equals 5 is the answer. And hunky-dory. All right, so now we're going to do the same thing, but we're going to do it in a more abstract manner because it's all variables. There aren't any numbers in there. So we do the same thing. We want to solve for A, so we isolate the A, we subtract C from both sides. So that gives you AB is equal to D minus C. So right there is the first mental block because people look and go, look, I subtracted 7, but 17 minus 7 is 10, so I could actually do it. Here, D minus C, I don't know what D is, I don't know what C is, so I can't do that. They're unlike terms, it just stays like that. And so that's usually the first mental roadblock that's thrown up where students think, well, I can't do that because you can't actually subtract those. You can't, but we're just trying to get A by itself, all right? So just like how we had A by itself there, then we divided both sides by 2. Here, we're going to divide both sides by B. And so now we have A, the B's cancel there, so A is equal to D minus C over B. And that's it. That is the answer. It doesn't feel like an answer because like we're used to this, where it's like A equals 5. But that's it. All right. This one is a little trickier because they want you to solve for x, but they have ax plus bx. And so what we have to do is we have to factor. We have to factor out an x. So I factor an x out front, and then whatever I write out front of the parentheses, I put it underneath, and now I reduce it term by term. So this, the x's cancel, I get an a. The x's cancel, I get a b. The plus is still there, and it equals C. So now you take a look at it and go, okay, well, just like how I had A times B here, and I divided both sides by B, I have X times A plus B here, so I'm going to divide both sides by A plus X, or A plus B, rather. I want X by itself. Too many variables. Ugh. So now look, when I take that binomial divided by the exact same thing, because it's being multiplied by the x here, I can cancel it. And so we have x is equal to C over A plus B. And again, if you want to put the parentheses on there, you can, but if you want to just leave it without, that's fine too. Solve for R, so here we go. We subtract T from both sides, and we get R over S is equal to W minus T. And so now this is interesting because they're dividing by S. So to undo that, we multiply both sides by S. And here, the S's cancel. Or if you want to think of it as over 1 and cross multiply and solve, you get R times 1 is R. Either way is equal to, and then S, we'll do the distributive property, SW minus ST. Okay. Lovely. Let's do number 4. Okay, so for q, so this time, this is an interesting little problem because we want to solve for q, so there's actually two ways to attack this problem. First, I think this is the easier way. Just do the distributive property. So you get pq plus pr equals s, and then you're going to subtract that off and divide by p. So we're going to subtract pr off. So we have PQ is equal to S minus PR. We're trying to find Q, so we divide both sides by P. Now, if you wanted to, this is fine. This is a good answer. We're good. You can say S minus PR over P. That's fine. Done. If you wanted to do that further, though, you could say Q is equal to S over P minus PR over P. Like divide everything by P. Divide by P, divide by P, divide by P. Well, does that do? Well, here I could cancel those P's then. And then I'd have this as an answer. Which isn't required. You don't have to do that. You can give me this answer. This is fine. But this is fine also. And then there is a third technique, a different way of doing it, where if we go back to the very beginning, what you could do, if you wanted to, is instead of, first got to write down the correct problem. P, Q, okay. What you could do, you were trying to solve for Q, instead of distributing the Q, divide out the P right off the bat, don't distribute it. And then you got Q plus R is equal to S over P, and then subtract R from both sides. And then you get Q is equal to S over P minus R, which is exactly the same as that. All right? So either way, any way that you want to do it is fine with me. I don't mind. I think doing the distributive property is a little easier to get your head around. But dividing the P out on both sides definitely is a little more efficient. It's a little faster. All right, so let's take a look here. 5a1 minus a sub 2x is equal to a sub 3. And for x. And so again, instead of like dividing, I'll show you. There's two ways to do this. I'll show you one way. So first way, to subtract a sub 1 from both sides. You get negative a sub 2x is equal to a sub 3 minus a sub 1. And then divide both sides by negative a sub 2. All right? And so when we do that, you can leave your answer like this. This is fine. Fine. With the negative on the a sub 2. I'm fine with that. The book doesn't let you do that. They multiply top and bottom, so they take it a step further. Instead of leaving the negative on the bottom, what they do is they multiply the bottom by negative 1 and they multiply the top by negative 1. And what that does is it makes the bottom term positive, all right? And then they usually rearrange it. Instead of writing negative a sub 3 plus a sub 1, this will be the answer that you find when you look on the back page. A sub 1 minus a sub 3 over a sub 2. That's fine. You do not have to do it that way. You don't. It's fine. This way is fine. That way is fine. I'll accept either one. Either answer is fine. All right? There is a third way. I was talking to a student and they said they did it this way, where they added a sub 2x to both sides and then solved. So then move the a sub 3 over. A sub 1 minus a sub 3 is equal to a sub 2x, and then divide by a sub 2. And so Same answer as that, a sub 1 minus a sub 3 over a sub 2. But all you did was you just kind of rearranged it before you divided. And yeah, whichever way you like is fine with me. Okay, so let's look at number 6. We got a is equal to h over 2 times b sub 1 plus b sub 2. I want you to solve for b sub 2. So I think, again, the easiest way to think about this is all over 2, like that. Because it's h over 2, that's like 1/2 times h. So h is on the top, 1h is on the top, 2 is on the bottom. Now, why do you want to rewrite it like that? Because now you can cross multiply and it'll make it a lot easier. Okay? So no more fraction to worry about. Now, I've had students say, yeah, I don't want to do that. I'll just multiply this by 2 and cancel it and multiply that by 2 and get 2a. That's fine. You can do it that way too. Same thing. And now we want b sub 2. So we distribute the h. And we subtract off hb sub 1. And we divide by h. And again, this is fine. 2a minus h b sub 1 all over h, just fine. If you want to divide by h, divide by h, divide by h, you can write this as the answer. Also fine. You just split up the fraction into 2 different terms. It's fine. Either one, either one. Doesn't have to be like that. It can be like that. All right. Okay, let's look at number 7. You got a square root in there. So f is equal to wv squared over gr, and they want me to solve for v. So again, we cross multiply and solve. So wv squared equals fgr. Divide by w. V squared is equal to fgr all over w. And then when we take the square root of both sides, you'll notice on my work, I always sneak a little plus or minus on it. But then my final answer, I just put down like so, just the positive, because usually in this course we're talking about voltage or, you know, some other entity where it can't be negative. Algebraically though, when you've got a second degree thing, there should be 2 solutions. But in practice, the domain restriction, if it's voltage, then it can't be negative voltage. So we just look at the positive version. All right. Let's do number 8. Oh, number 8, I could squeeze it over here. So f is equal to km1 m2 over d squared for d. All right, so really same dog, different fleas, right? We just put that over 1, cross multiply and solve. So you have f d squared is equal to k m sub 1 m sub 2. And then divide by f and take the square root. So d squared is equal to k m sub 1 m sub 2 all over f, and square root both sides. Again, there really should be a plus or minus there, but we're going to disregard the negative. And there we go. Make sure that you make your square root sign clear, that it captures the f. Don't make me guess if it's all over f or if it's under the square root sign. All right? Okay. Number 9. Is r sub t is equal to d r sub 1 plus d plus 1 r sub 2 for r sub 2. Okay, so now this one we do not have to distribute because we just have to factor it again. We're just going to leave this in a holding pattern because they want me to solve for this. If they would have wanted me to solve for like d, then I'd have to distribute it and then do a bunch of work. But since they don't, I don't have to distribute. We're just going to leave that like that. We'll subtract dr sub 1 from both sides. So that's r sub t minus dr sub 1 is equal to d plus 1, quantity d plus 1 times r2. And now divide by plus 1. And then those cancel, and then that's it. R2 is equal to r sub t minus dr sub 1 over d plus 1. Ha, R2, get it? C3PO R2. R sub 2, I guess. It's a little different. So r sub t minus d r sub 1 all over d plus 1. How much time? Okay, about 16 minutes. I can do 1 or 2 more. Here, wait, I've got an R2. I've got a lot of R2s. In a different part of the basement, I've got a different R2. Look, R2. R2! Here, we'll put them up here. It's blocking Superman a little bit. Yay. R2. Okay, number 10 is P equals W times X minus Y over M times S minus T for M. And again, this isn't that bad. I mean, it looks bad with all of the variables. But look, that's over 1. We cross multiply and solve. So you have P times M times S minus T equals W times X minus Y. Quantity X minus Y. And now you just divide everything that's not an M. We want M. So we're going to divide out P and S minus T. P and S minus T. The P's cancel, the S minus T's cancel. I have just M is equal to W times quantity X minus Y over P times quantity S minus T. All right. So that one isn't bad. 11, that one is a little tough. We have to do H is equal to FG plus F minus 1 times T, but they want me to do it for F. And so we do the distributive property. So you got H is equal to FG plus F little t minus T. We add the T over to the other side. So H plus T is equal to F times FG plus FT. All right, but now I want F, so I'm going to have to do what I did in the first page there. I'm going to have to factor out an F. So that's like undistributed it. I put an F down, I do an empty set of parentheses, or whatever I write down there. I divide it out. I end up with G plus T, H plus T. All right, and now we just divide both sides by G plus T. And now you've got to be sharp about this. You can never, ever, never cancel anything. Look, it's H plus T on the top, and it's G plus T on the bottom. But you cannot cancel those T's. They're being added. When things are being added or subtracted, you can't get rid of them. You can get rid of them if you divide it by the entire binomial. Then you can cancel it out. But if it's being added like that, it's this entity divided by this entity, and we cannot take out pieces of it. When there's add or subtract, you cannot cancel anything. Be very careful about that. That is a very, very common error. All right, and here we'll do one last solve one, and then we'll do the second half will be the graphing parts. Deal with graphs. So this will be the last one. Number 12, a squared minus b squared equals c squared for b. And so again, you can do it two ways. You could move the b over to this side and the c over to that side. That's probably the easiest way. Let's do it that way. It adds a step, but it's just easier than dealing with the negatives. Like dealing with the divided by a negative and then flipping all the signs and all that. So I move the b squared over to that side. I'm moving the c squared over to this side. So a squared minus c squared is equal to b squared. And now I'll take the square root of both sides, and I put the plus or minus there, but again, it's a distance, so I'm only going to leave the plus. Ooh, also very, very, very important. We do not distribute a square root over a plus or a minus. For the same reason that we couldn't cancel these t's, you cannot put a square root over a plus or minus. I've had students tell me, oh, so it's a minus c. No, it's not. You can't distribute a square root over a plus and a minus. So that's the square root of that. All right? Okay. I'll do a second video on review 2, part 2, or review whatever this is, chapter 9, 10, part 2.